It's true. You can use a microwave to measure the speed of light. But let's talk about microwaves. Microwaves are part of the electromagnetic spectrum and they fall between radio waves and infrared radiation. Microwaves are characterized by their wavelength and their energy. Microwaves oscillate as they travel through space. This means they move back and forth in a repeating pattern. Microwaves are so interesting because they move at the same speed as light does. And to measure the speed of light in a microwave, we will use an equation. The speed of light equals frequency times wavelength. Frequency is the number of cycles per second that an oscillation occurs. We'll be measuring frequency in hertz, or cycles per second. Finding the frequency is the easy part, and it can be found on the side or the back of your microwave. On this microwave, it is 2,450 megahertz, or 2,450,000,000 hertz. To find the wavelength, we'll be using a chocolate bar. So what I'm going to do is I'm going to open up the microwave, and inside is that rotating tray. We're going to take that out, and also this little plastic piece as well. We're doing this because we want the oscillating microwaves to hit the chocolate at the same spots over and over again. So let's take our chocolate, put it on a plate. I'm going to put it right in the center of the microwave. Alright, there we go. Ready to go. We're going to heat our chocolate on high for 15 seconds. Alright, and let's see what happens after those 15 seconds. You can see there are two hot spots on the chocolate bar. We're going to measure the distance of these two spots, and that's going to help determine the wavelengths of the microwave that the oven produces. Now I'm going to grab my ruler and I'm going to measure the distance between these two spots, and I'm going to do that in centimeters. So let's take a look. All right. Well, kind of looking like 6 centimeters or so. Always want to kind of, this is our best guess, this is our best guesstimate. So from kind of like the middle of one spot to the middle of the next hot spot. Let's go with 6 centimeters. And 6 centimeters is only half the wavelength that the oven produces. If you double the distance, you'll have the length of the waves emitted by the microwave, 12 centimeters. Next, we're going to plug in the frequency and the wavelength into the formula and calculate. So your final answer will be 29,400,000,000 centimeters per second, which is pretty close to the speed of light in a vacuum, and you can see that number below. So with just a ruler, a chocolate bar, and a microwave, we were able to measure the speed of light. You can try this experiment at home and see if you get similar results. And at the end, you can still eat the chocolate bar.